Hi, we're going to talk about the rational zeros theorem, also known as the rational roots theorem. What this does is allows us to find the factors of a polynomial where otherwise we wouldn't be able to factor it. So this is using the variables p and q to kind of talk about that, where p are the factors of the constant and q are the factors of the leading coefficient. So looking here, p comes from 3, so our factors of 3 are 3 and 1. And q comes from 2, and our factors of q are 2 and 1. Then we're going to do p divided by q, which we note right up here. P divided by q, that means we take each of these values and divide it by each of these to get our possible rational roots. So we'd have 3 over 2, 3 over 1, 1 over 2, and 1 over 1. And these are our possible rational roots, which means if it's going to be able to be factored with rational numbers, it's going to be one of those numbers. And we also know by looking at our highest exponent how many zeros or roots there are. Now some of those could be repeated roots, but at most this will have 3 roots. So let's actually do an example with this. So we're going to talk about this one right here. So like I said, the p comes from the constant and q comes from the lead coefficient. Well, when there's not a lead coefficient written there, the lead coefficient is 1. So if I write down all the factors of p, so that would be all the factors of 30. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 5, plus or minus 6, plus or minus 10, plus or minus 15, and plus or minus 30. And then q are the lead coefficient factors. Well, the factors of 1 are just plus or minus 1. So I'm going to use those to actually find the possible rational roots. So that means I'm going to take and do every p divided by every q. This one's a little bit easier because there's only one q there. So with that being said, I'm going to take each of these values and divide it by 1. So it's really just going to be each of those again. So I'll have plus or minus 1, plus or minus 2, 3, 5, 6, 10, 15, and 30. That means if I'm going to have a rational zero to this function up here, it's going to come from this list right here. This does not take care of imaginary numbers, imaginary roots, or irrational roots. Now, the long way to go about testing this is to do synthetic division and divide each of these values out to determine that. You could also do some Descartes' law of signs, but the easier way when we're doing distance learning here is to actually just use the calculator. So on our graphing calculator, we're going to type in the original equation into our y equals. So x cubed minus 19x minus 30. So once I have that, then I'm going to go through and actually figure out some of the zeros. So here we're going to see if I can zoom in a little bit on this. Okay, so we're going to go second graph to go into our table. And we are going to test each of these values to see which one gives us 0 as our y value. That's what makes it a 0. And you've got to remember to test positive and negatives. So I've got 1 and positive 1, 2 and negative 2. So right there, negative 2 gives us a 0. So I'm going to mark right over here and say, okay, x equals negative 2. And I'm looking for a total of 3 zeros here because it was an x cubed. So 3, negative 3. Oh, negative 3 is another one. So I'm going to say x equals negative 3. 5, there's our other one, 5, x equals 5. So that gave me all 3 values. So I'm going to zoom back out here so you can see everything. Maybe. So if my original equation was an x cubed minus 19x minus 30, so I'm looking for those 3 values, and I've got all 3 of them right here. So that means my factored form for h of x will be h of x equals and then I'm going to do x minus each of those zeros. So x minus a negative 2, which turns into plus, x minus 3, negative 3, and x minus 5. So if a problem asks you to write it in factored form and list the zeros, these are the answers we're looking for. So let's do another example. So I'm going to flip this page over. So now we're going to do 4x cubed plus 8x squared minus 3x plus 9. So once again, p is going to come from here, q is going to come from here. And bear with me, I just started up a calculator, so it's probably going to, there we go. So all my factors of p, so all the factors of 9. So 1, 3, and 9. And then my factors for q, q comes from the 4. So I've got 1, 2, and 4. Sorry, lots of things. There we go. And then I'm going to do p divided by q. This is going to give us a little bit longer list because I've got 3 numbers here and 3 numbers here. So I'm going to take each of these p's and divide it by each of the q's. So I'm going to have 1 over 1, 1 over 2, 1 over 4. Then I'm going to have 3 over 1, 3 over 2, and 3 over 4. Then I will have 9 over 1, 9 over 2, and 9 over 4. So those are our values that we're going to look at. So once again, we're going to type the original equation here into our graphing calculator. And I did pop up a graphing calculator here so we can do that. So feel free to pause if you need to so you can, oops, wrong thing. It doesn't like me typing that. Okay. We've got 4x to the third plus 8x squared minus 3x minus 9. So go ahead and pause here if you need to take another minute to type this equation in. We're going to jump on ahead. So we're going to go second graph. And we can already see in our menu here, we've already got one of our answers. So I'm going to pop this off to the side here, which makes it kind of small, but it'll work. So I can already see one of those answers is 1. So I have x equals 1. And once again, I'm looking for 3 answers. So x equals 1 is one of those answers. Let's see if I can shrink that down and make that a little bit bigger. So I'm going to just start typing in. So I've got 1. Does not like me typing negatives. So negative 1 doesn't work. Let's just try 1/2. I'm going to try all the positives first. 1/4, 3, 3/2, 3/4, 9, 9/2, and 9/4. I don't have any other positives. It really means I have a whole slew of negatives I can check here. So I've got a negative 1/2. I've got a negative 1/4. Back up to the top here. So negative 3. Negative 3/2. Oh, there's another one. And I would write it as a fraction because we're going to have to do something with that because you cannot leave a fraction in those factored forms. So negative 3/2, where I'm at, negative 3/4, negative 0.5, negative 9, negative 9/2, negative 9/4. Okay, so notice we only got 2 of our 3. And it could be because I just missed one when I was checking them, but I'm going to show you what to do when that is the case, because there is an extra step here to do now. So this is when synthetic division comes in. All right, so I'm going to bounce this down here. Remember our very original equation is 4x cubed plus 8x squared minus 3x minus 9. So now I've got to synthetically divide out these two factors to try and find that third one. So that means that it does not matter which one you start with, but I'm going to put a 1 here. I'm going to use that one to start with. And then I'm going to do my synthetic division. So drop your first, then multiply and add, multiply and add, multiply and add. Remember, the last one is your remainder. And if you did it correctly, you should get 0. If you got these two factors up here to work, that should be 0. Oop, can't see that. Then from this one, I'm going to synthetically divide out the other one, which was a negative 3/2. So I'm going to drop my 4, and then I'm going to do negative 3/2 times 4. If you don't know how to do fractions in your head, that's okay. You're welcome to use a calculator, but I'm going to show you a shortcut. 4 divided by 2 is 2, times negative 3 is negative 6. Then we add in 6. 6 divided by 2 is 3, times negative 3 is negative 9. And that drops to 0. That's our remainder for that one. So I'm left right here with 4x plus 6. That means I can find my third one by just setting that equal to 0. And the reason why that's just 4x is because, think about it this way. This was an x cubed, and I took one away. So then I have an x squared. I took another away. Now I'm down to x. So if I solve this out, I'll end up with 4x equals negative 6. And if I divide by 4, x equals negative 3/2. So coming back up here, this one actually has a multiplicity of 2. That means it happens twice. So let's go up and write this in factored form. So I'm going to erase just this part here. So factored form, this one is very easy to do. This one's going to be a little bit more of work. So my factored form, h of x equals, I'm going to have x minus 1. And then this one right here, because of the way it is, we've got to basically get that equal to 0. So you'd multiply by 2, so I'd have 2x equals negative 3, and add 3. So 2x plus 3. So I'm really kind of unsolving it. This is actually what you're going to write. So the coefficient of the x always starts in the denominator. So it's going to be 2x plus 3. And the fact that it's a multiplicity of 2 says it's squared. So if they're wanting all those answers, factored form and zeros, those are going to be your two answers on this. Hopefully this video helps and is not too overwhelming. So good luck.